9.8 is solving exponential functions and logarithmic equations. And this is a really important section because it kind of puts everything in chapter 9 all together. And this is something that will absolutely be on your final. So you need to pay close attention to every problem. And you need to text our class mentor if he can help you. Make sure you study this section really well. The only additional thing they add to this than what you already know is that if you have the log base b of anything and it's equal to the log of that same base of something else, it's legal to take those logs off of both sides. Or if you just have a equals c, you can actually take the log of both sides. So you can go from one to the other. And that's the only additional step that you might need in this chapter, chapter 9, from what you've already learned in the other sections. So it starts out and it says solve, and you might see something like this. Now before, we could make the bases the same and just drop them. Do you remember that? But there's no way to make 2 and 5 the same. Like, we can't change the exponent and make those equivalent. So what we have to do is find a way to get that variable out of the exponent. So guess what? That's exactly what logs are for. So I'm going to take the log of both sides. I'm going to take the log of 2 raised to the x and the log of 5. And notice I didn't write a base, so that implies that I'm using base 10, which also means we can use our calculators. And so that's our best way to go. And as long as I do it to both sides, it's legal. Now I can use my log rules and just pull that exponent down in front. So I can now write x log 2 equals log 5. Then I just need to get x alone, and we can get that alone by dividing both sides by log 2. And as long as you do it to both sides, it's legal. And anything divided by itself is 1, so that's gone. And my answer is now the log of 5 over the log of 2. And if they want the exact answer, you're done. If they want the approximate, now you punch it in your calculator. And so if I punch that in my calculator, I will get 2.3219, and they do go 4 decimal places. Another thing they could do, let's make it a tinge bit harder. Well, a little bit different problem. They write the log of base 6 of x plus log base 6 of x plus 1 equals 1. Now, this is different because right here we had a log on both sides. Right here we didn't have any log. But here we've got 2 logs on one side and none on the other. So what we're going to do is what we learned earlier in this chapter and condense those and make them 1 log. So to condense them, because they're both log base 6, I can write them as 1 log, and we know that we change plus into multiply. So I have log of 6, and then I have log base 6 of x times x plus 1. Now that I only have a log on one side, we've actually done this before, I can now convert that to exponential and get rid of the log, which gets the variables out. Right now they're locked up inside this log. So my base is 6, right here's my base. My exponent is what the log is equal to. So I have 6 raised to the first power equals, and my answer is what you're taking the log of. So I have that x times x plus 1. So then let's just go one more step and distribute that x. And some people do that up here, and that might have been good to do. But now this is complete review. You should know what to do when you have x squared and x. To solve, we're going to have to do that f word. We're going to have to factor. So before we factor, we know it has to be equal to 0. Then I can factor. And you might need to factor by grouping. You can factor however you like. But I can see that 3 times 2 is 6. And if 3 is positive and 2 is negative, I'll get negative 6. And the outside and the inside will add up to 1 right there. Alright, now setting each factor equal to 0 and solving, I get -3 and 2. Now the problem is with a log, remember we've graphed logs before, and the graph of a log looked like this. Do you remember you always had that stable point over 1 right there? And it went like this, and it got closer and closer and never passed that asymptote. So if you're plugging this number in up here, and it makes you take the log of a negative. So if I plug in 2, I'm taking the log of 3. If I plug in 2, I'm taking the log of 2, so we're good. But if I plug in -3, I'm taking the log base 6 of -2. And that's over here somewhere where there is no graph. So the rule is you cannot have answers that make you take the log of a negative number. So this is not a solution, and that is. And this is important because this very type of question could be on the final exam. And A might be both of those. And B would be -3, and C would be 2. You need to pick 2. Remember, you can't take the log of negatives. Okay? Alright, let's try another one. How about this one? Let's do the log of x minus 1 minus the log of x equals 1. So once again, we have two logs, and we need to begin by condensing them. And I know that condensing means that since I'm subtracting, I will divide by x. And I know that there's no base here, which implies that the base is 10. Hopefully you all knew when nothing's there, it's 10. So now to get these variables out of the log, I'll convert to exponential. And my base is 10. My exponent is what the log is equal to, 1, equals, and my answer is what you're taking the log of. So that's my answer. So now, again, I'm just back to an algebra problem like we solved early on. I know I need to get that out of the denominator, so I'll times both sides by x. So here it reduces, and here I have 10x, because we know 10 to the first power is just 10. And then I don't have x squared, so now I just need to get x alone. So I'll get it together by subtracting x from both sides, and then I can get x alone by dividing by 9. So x equals -1/9. Now, plug that in. Oh, look, that makes me take the log of a -1/9 right here. And this one makes me take the log of -1 and 1/9 here. So it clearly does not work. And that's our only answer. So our answer is no solution. And you can just use this symbol for no solution. Alright, let's try this one. Last one. Let's say we're supposed to solve e raised to the 2x equals 8. Now once again, our variable, it's just like this one that we saw right up here. Our variable is in the exponent. So to bring it down, I need to take the log of both sides. And that would work, but because I have an e in the problem, it will simplify our work if instead of taking the log, we take the natural log of both sides. And you'll see why that's convenient in just a second. But we take the log or the natural log of both sides. Then we're able to pull our variable down so it's not locked up in the exponent anymore. Now here is what is nice. You might remember this rule. If I have the natural log of e and I want to figure out what it equals, I would convert this to exponential. So my base right there that's implied is e, and I have e raised to the question mark equals e. And for those to be equal, what do those question marks have to be? 1. That will be equal if that's 1. If e to the 1 equals 1. So this is what's really nice. Whenever you see the natural log and e together, and we probably already covered that, it will always go to 1. So it's just gone. It's like you have 2x times 1. So now I just have 2x equals the natural log of 8. And then to get x alone, I would divide by 2. And once again, if they want the exact answer, you're done. If they want the approximate, you punch it in your calculator. And if I punch that in my calculator, I will get 1.0397. And once again, you'll see a log equation on your final exam for sure. So this is an important section. Please email me any questions. Please text our Tarek, our class mentor, any questions, and really get this section down solid.